Hi students, today in this lecture we are going to draw an isometric view for this component. So firstly we are going to define the extreme sizes of this component, that is total length, total height and total width of this component. See, to define the total length, see here there is 25 mm, this is a 50 mm, it is given in the top view, and it is given from the center of this hole to the center of this cylinder, and the outside diameter of this cylinder is 40. It means its radius is 20 mm. So 20 plus 50 plus 25, that is 70, plus 25, that is 95. The length of this component is 95 mm. Then the width of this component is 40 mm, and lastly the height of the component is 40 plus 15 mm, that is 55 mm is the height. So firstly we are going to prepare a block of this size. So like this I prepare block for this. So in this component the length is towards left side of O, that's why I mark the length on the left side of this O, width on this axis and height on this axis, and the block will get complete. Now in this we are going to start from the cylinder. So see the sizes of the cylinder. The OD of the cylinder is 40 mm and the height of the cylinder is also 40 mm. So firstly we locate the center for this cylinder. So if you observe from O point, the center or the cylinder is towards left side in the top view. It means from O side, O point, it is on left side, it means here. Then if you observe its front view, it is at the top portion, it is meant it is in this plane. So in this plane firstly we locate the center line for this cylinder. So as we know, the width of this component is also 40 mm. So locate the center at 20 mm. I am going to locate 20 mm here also to avoid any mistake. Right, similarly for this center line, this one center line, it is from 20 mm from the left side. So I locate 20 mm from left side here. Like this we get the center for this cylinder. Then we are going to prepare a rhombus here for the diameter size, that is 40 mm. So this is 40 mm, this distance is 20 mm. So just we have to mark 20 mm on this side so that our block get complete. There is a rhombus. Now in this rhombus we get the 4 angles, this 1, 2, 3, 4. Out of these 4 angles, firstly I identify 2 obtuse angles. This is first obtuse angle, this second obtuse angle. So through these obtuse angles we will draw the line on the opposite faces center. So from this corner join the line on this corner, this face center, and for this here. Similarly from this second obtuse angle, like this up to here. Like this. Then we'll draw this ellipse. So take this distance. Firstly check whether this is correct or wrong. This is the first curve. Then by using this as a center and this much as a radius, sorry. This is a curve. Another two centers are this one, this is. So use this center and this much radius. Check whether it is correct or wrong. Similarly, this one also. So this is our external circle of this cylinder. Then the height of the cylinder is 40 mm. So we'll draw 40 mm tangent to this cylinder. As this cylinder is vertical, that's why we'll draw tangent of 40 mm vertical like this. Similarly, we'll draw on this side, but it should be in thin line because there is a compound on this side. That's why I'll just draw it in thin line. Then the bottom portion of the cylinder will parallel to this curve. That's why whichever the centers we use to draw this curve, we'll shift that centers also by 40 mm downward. It should be in very thin line. Like this. Then using the same radii, this means this one radius or this one, both are same. That's why I take, firstly we'll take this radius, use this as a center, complete this portion up to here only, then from this center and lastly take this radius, or this one radius, both are same, so you can take any radius. And to complete this up to here, that is sufficient because on this side there is a plate, so there is no need to join that. Then we are going to draw the inner hole for this cylinder. The inner hole is having size of 520, so we will prepare one more rhombus of 20 mm size. So 10 mm on both sides of the center, 10 mm here, 10 mm on this side. Similarly on this side 10 mm and on this side 10 mm. Then draw parallel line to the center line through this point and through this point also, and similarly parallel to this center line through this point, secondly this. Now remember one thing in here, that this line should be parallel to this center line of this cylinder. So I locate first obtuse angle, then draw the lines on the opposite face center, this one, Similarly on this side. Right, so we'll get 4 centers, 1 2, I highlighted here, 3 and 4. By using these centers, we'll draw the inner hole. Take this radius, check it first whether it is right or wrong. Then draw this. Similarly use this center, this same radius. And this radius. This is very small circle, that's why it is quite difficult to draw such type of ellipse. So here you can use pro circle also to draw this. By measuring this radius you can use this. Now after this we'll draw the next plate to the cylinder. So the sizes of this plate is 40 mm and this plate is in front of the component. The width of this plate is 30 mm and the height is 40 mm. So we locate here the center first. And then mark, as the width is 30 mm, so 15 mm on both sides, 15 mm here, 15 mm here, right? And the height is 40 mm, 40 mm is the height. So from this point parallel to this, here also 40 mm. Like this, and here there is a corner is there, that's why this corner will appear in the isometric view as a line like this. Then this line is extended up to the cylinder, and here there is a 12 mm thickness of this plate, that's why parallel to this thick plate, then extend this line up to the cylinder. But I don't know the length of this, that's why I just draw it. Afterwards we are going to confirm that. Then parallel to this, and here this plate size is 12 mm, this is 40 mm, this means this line is from here to here, it is 28 mm. So parallel to this line we'll draw line through this corner, and the length of that line will be 20 mm. That's it. Then parallel to this line. This length is also I don't know, that's why we'll just draw it. Then we'll draw this taper first, after that we can confirm that. That's why this taper extends up to the 30 mm from the center, 30 mm from the center, and if you calculate it from this point, so this center to this plate portion, plate end portion is 75 mm, and this is 30 mm, it means from this point to this point it is 45 mm. So I locate center here first, and I'll draw a center line parallel to this, and as the same, this point is 45 mm from this point, so we locate 45 mm from this point. It will be here. Then the width of this plate is 12 mm, so we draw parallel to this line. Or we can join this point with this point. This will be easy. Like this. Then you can mark 12 mm here. Right, then parallel to the center line, like this. Similarly from this point. Okay, then as a support, draw first vertical line and then this horizontal line parallel to this line. Like this you can complete this plate. Then as this plate is connected on this plate or rest on this plate, and here it will be a radius which will be parallel to this, it means same center we are going to shift by this much height, and this much height means it is given here, that is 15 mm. So we shift the same center by 15 mm here vertically, then use the same radius that we used last time, this much or this much, anyone. Then use this 15 mm center and see it will match here. Then draw arc up to this extended line like this, and then you can draw this line, you can confirm this line up to this arc like this, then vertical to this, parallel to this line, vertical line from here, and the plate will get complete like this. You can confirm this plate also now, because already we have drawn this and the end point of this. That's it. Then two more circles are there, two more holes are there in this component. One is on this front face and second is on this top face. Because this dimension it is given 5, 12, 2 holes. So one hole is this one and second is obviously this one. So this is located on this portion and second one, this one is located here. So firstly we draw this portion, this circle on this portion. So this is a 25 mm center is located. So we locate center first at 25 mm. So we'll draw center first, and the diameter of the circle is 12 mm, so we mark 6 mm on this side, 6 mm on this side. Similarly, six mm here, 6 mm here. And so like this we prepare the rhombus of 12 mm around the center. Then this is obtuse angle and the second obtuse angle in this rhombus. So we'll join the lines on the opposite face centers like this. And we'll get the center here, 4 centers, these 2 centers, and at the center intersection this is second, third, so 4 center. By using these centers We'll draw rhombus, use this as a center, this much as a radius, and draw this curve first. Use this center, this much as a radius. Like this. Then this as a center, this is last point distance. Complete this. Then this as a center and this much as a radius on this side. Complete this. So like this we prepare this ellipse. Similarly we'll prepare the circle on this face also. This also having diameter equal to 12 mm and its center is this from here, this is 28 mm, center of this 28 mm, this is 14, so from below 14 mm, and the center of this width. So already we have located center here, so join the center first by using center line, and from bottom mark at 14 mm the center for this. From here also 14 mm above, join the center line. Then as the size of the hole is 12 mm, so here also we locate our rhombus of 12 mm size, 6 mm on both sides of the center. Then identify the obtuse angle. This is one obtuse angle, this is second obtuse angle. Through this obtuse angle we'll draw line on opposite face centers like this. Then throw up to this obtuse angle opposite face centers. So here also we'll get the 4 centers, first, second, third and the fourth. By using this as a center and this much as a radius, draw the first arc, then use this as a center and this much as a radius, draw the second arc, then this as a radius, center and this much as a radius, draw this third arc, and lastly this as a center and this much as a radius, draw the last arc. So like this we complete the isometric view for this component. So don't forget to click on like button, comment if you feel any query or any doubt regarding this component or isometric projection. Thank you students.